Alright, so automated gates, they're pretty common, but I bet most people don't think too much about what goes into making sure they're actually safe and compliant too.
Yeah, it's easy to forget about that part, right?
Totally, especially with something we use almost every day. But you've given me a lot to work with today. We've got one document on maintenance frequency, another that seems to cover every UK regulation under the sun.
Yep.
And then this one called How Sliding Gate Rolling Gear Affects Safety, which honestly I'm pretty curious about.
Good stuff.
But first, let's start with the legal side, since that affects pretty much everyone listening. You always explain things so clearly, so tell me, when we're talking about automated gates in the UK, what are the essential laws or regulations that someone like, I don't know, a homeowner or maybe a property manager needs to be aware of?
Well, you've got several key pieces of legislation to keep in mind. There's the Supply of Machinery, the Safety Regulations 2008, the Health and Safety at Work Act way back from 1974.
Yeah.
Even the Workplace Directive comes into play.
Wow.
And of course, you can't forget about the Electricity at Work regulations.
So electricity is specifically addressed?
Yeah, for sure. Lots of potential hazards there. And then you've got the building regulations too, so it gets pretty complex.
That sounds like a lot to keep track of. Is there like a central theme or a main takeaway that ties all of these together?
Definitely. The key concept that underpins all of this is shared responsibility.
Shared responsibility.
Right? It's not just on the manufacturer to ensure the safety of these gates. It extends to installers, owners, landlords, really anyone who plays a part.
So it's not like, say, buying a toaster, where if it malfunctions, it's the manufacturer's problem.
No, not at all. These documents really emphasize what they call reasonably practicable safety measures. That means going above and beyond just the bare minimum requirements.
So it's not enough to just install it according to the instructions and call it a day.
Exactly. You've got to meet the standards that are outlined in publications like BSEN 13241, for example. They define what's considered the state of the art in the field.
Makes sense. You don't want to be using outdated practices when safety is on the line. So, speaking of best practices, this naturally leads to a question about maintenance. How often should these gates be looked at? Is there a magic number hidden somewhere in these regulations?
That's where things get really interesting. You won't find a specific mandated maintenance interval in any of those laws.
Wait, really? So there's no hard and fast rule, no check it every 6 months or anything like that?
Yep.
Wow, that surprises me. That seems like it could cause problems.
It can, and it often does, which is why we're diving into this. Even though there isn't a set time frame, the responsibility still falls on the manufacturer to provide what they call a maintenance regime.
Okay, so the manufacturer needs to at least give some guidance.
Exactly. They need to say something like, this gate should be serviced every X months, or make sure you check these components annually.
That seems reasonable. They built the thing after all.
Right, and the DHF, which stands for the Door and Hardware Federation, is very clear about this.
The Door and Hardware Federation.
Yeah, they're kind of like the experts in this area.
Got it.
And they say that if a manufacturer doesn't provide a plan, or if their plan isn't good enough,
Let me guess. Someone else has to step in and figure it out.
you got it. It falls on the installer or the owner, basically whoever's responsible for the gate, to come up with a maintenance routine. And it can't be just any old routine. It has to be based on how well they understand that specific gate, their experience, what they observe over time.
That's a lot of pressure, especially if something goes wrong.
It absolutely is. And sadly, that's often when we see inadequate maintenance becoming a serious issue. Like the DHF document even talks about how competitive pressure in the maintenance industry leads to more reactive rather than proactive service.
So it's cheaper to fix it when it breaks than to keep it from breaking in the first place.
Yep.
That's a little worrying.
Yeah, that's a big concern. And that leads us to a point that I think often gets missed in these discussions, the actual design of the gate itself.
Okay, so how the gate is built plays a role in how often it needs attention.
Hugely. I mean, think about it. The design, the components that are used, all of that has a massive impact on how often maintenance is needed and how safe that gate stays over its lifespan.
It's all connected.
Exactly. And you can see this really clearly in that document you shared.
About the rolling gear.
Exactly. It really gets into the nitty-gritty of how design choices, even down to the materials they use, can make or break a gate's safety and maintenance needs over the long term.
I'm guessing over-engineering is a good thing in this case.
Absolutely. If you build something to last, to withstand more than it needs to, you're inherently making it safer and reducing those maintenance demands.
So it's like building a car with off-road capabilities, even if you're only ever driving in the city.
That's a great way to put it. You're prepared for the unexpected.
Yeah.
And another thing the document highlights is the use of self-lubricating parts.
Oh, that's smart. Less maintenance right off the bat.
Yes, exactly. And then there's this idea of planned component replacement, which I think is brilliant.
What's that?
It's like knowing from the get-go that certain parts have a limited lifespan, and then you design the gate in a way that makes it super straightforward to replace those parts when the time comes.
So it's not a scramble to figure out how to fix something buried deep inside the mechanism.
Not at all. It's about anticipating potential problems from the very beginning, not just waiting for them to pop up and then trying to play catch-up.
That's smart engineering. Anticipate and plan for everything.
Absolutely. And this might seem obvious, but the environment a gate is exposed to makes a huge difference too.
Oh, for sure, like a gate on the coast is going to face completely different challenges than one in a sheltered courtyard.
You got it. Salt air, rain, wind, those all take a toll. So you need to factor that into your maintenance routine too. You can't just have a one-size-fits-all approach.
It's like the difference between maintaining a car in the desert versus the rainforest. Completely different environments, completely different challenges.
Exactly. And this is where things get even more interesting.
Right, like different maintenance schedules, different specialized parts maybe.
Exactly.
But, okay, so we know these gates need attention, we know the design and environment play a role, but let's talk about the hazards themselves. It's one thing to say, maintain your gate, but I think it's helpful to understand what could actually go wrong if you don't.
Absolutely. And some of the hazards might not be so obvious.
Besides the obvious one, which is getting crushed.
Even then, there are nuances.
Oh, like what?
Well, the automated gates document actually breaks down these hazards really well.
Right.
So, yeah, you've got crushing, which is what most people think of first.
Yeah.
But then you've also got the risk of impact.
Impact, like getting hit by the gate.
Exactly. It's not always about something getting caught in the mechanism.
Right.
And then there's shear.
Shear? What's that?
That's like a guillotine effect.
Oh, wow. Okay, that's not good.
No, not at all. And then, of course, you've got drawing, where something gets pulled into the gate's workings.
So that's where someone or something gets trapped.
Precisely. And those can be some of the most serious hazards.
It's easy to imagine those things happening with a swinging gate. But what about sliding gates? Are the hazards the same?
They can be. But sliding gates also come with their own risks. Like, think about the potential for structural issues.
Structural issues like what? The gate falling apart?
Well, it could be something like that, yeah? Or derailing from its track.
Oh, right. And then there are the electrical components to think about. We don't want any shocks or fires.
Exactly. Electricity adds a whole other layer of complexity and risk to these systems.
You're really painting a picture here of how many things need to work perfectly to make these things safe. It's making me a little nervous, to be honest.
I get it, but don't worry, we're not just going to leave you hanging with a list of terrifying possibilities. The document also talks about control measures, which are ways to mitigate those risks.
Okay, good. Tell me more about those. What kind of things are we talking about?
So, just like with the hazards, these control measures, they aren't all created equal.
Meaning some are better than others.
Exactly, and knowing the limitations of each one is really crucial.
Right, so walk me through it. What are our options here?
Well, a common one is the hold to run system. Basically, you have to keep a button pressed for the gate to move.
So it won't move unless you're actively telling it to.
Exactly, so it forces you to be present and aware, which can prevent some accidents, but it's not exactly convenient for everyday use.
Right, like if you've got your hands full of groceries or something.
Exactly. Then there's something called inherent obstacle detection.
Inherent obstacle detection. Okay, that sounds promising.
It is. It means the gate's motor can sense if it encounters an obstruction and will stop.
So it's like it has a built-in sense of touch. That's really cool.
It is pretty amazing technology.
Yeah.
It's good, but it's not foolproof.
Oh, how so?
Well, it's great at detecting something hitting the gate, but it won't always catch those draw-in situations.
Because it's reacting to something physically blocking its path, not something being pulled into the mechanism itself.
Right? And for those situations, you might have something like safety edges.
Safety edges? What are those?
They're like pressure-sensitive strips that will trigger the gate to reverse if they encounter an obstacle.
So, if something or someone bumps into it, the gate backs up.
Exactly.
That sounds like a good catch-all.
They're pretty good, and they can be used to address multiple hazards, but again, there are limitations.
Like what?
Well, they can be defeated.
Defeated. How?
Let's say someone gives it a good kick in the wrong spot. It could disable the safety edge.
Oh, I didn't think about that.
It's all about understanding those vulnerabilities. And then, of course, you have what many consider the gold standard, light curtain.
Light curtains. Okay, those sound serious.
They are, think of them like invisible walls of safety.
Invisible walls. I like it.
They're really hard to bypass and offer that high level of protection we're looking for. The downside, they can be,
They're probably expensive.
yeah, and more complex to install, but when it comes to safety, it's often worth that extra investment.
For sure. I mean, we're talking about potentially saving lives here.
Exactly, and it's important to remember that even a single beam photocell, which is a common safety feature,
Yeah, I've seen those.
they're better than nothing, but they're super easy to bypass. Someone could just step over the beam and the gate wouldn't even notice.
Wow. Okay, so we've gone from better than nothing to invisible fortress with these control measures. That's quite a range. You know, something that surprised me while reading through all this was how much emphasis was placed on the rolling gear.
The rolling gear.
Yeah, it seemed like such a small detail at first.
It's easy to overlook, but you're right, it's incredibly important. It can have a huge impact on how safe your gate is and how often it needs attention.
The document actually uses track alignment as an example. Even if it's off by a little bit, it can strain the whole system.
Exactly. It's all about minimizing friction. Think of it this way. Every bump, every tight spot, it's putting extra stress on every component. And that not only leads to more wear and tear, but it also means the gate has more inertia.
Inertia, meaning,
Meaning it takes more force to get it moving, and once it's moving, it's harder to stop.
oh, I see where you're going with this. So, if the gate is harder to stop, those safety features we talked about, they might not react in time.
Exactly. A smoothly running gate isn't just about things looking and sounding nice, it's fundamental to the safety of the entire system.
It's all connected. Form follows function.
I like that. And the type of components matters too. Like, take cantilever gates for example.
Those are the ones that slide back on a kind of counterbalanced arm, right?
Exactly. They've got those adjustable offsets, and getting those adjustments just right is crucial.
How precise are we talking?
We're talking millimeters. Even being off by a tiny bit can make the difference between a smooth, safe operation and a system that's under constant strain.
Wow, okay. I'm starting to see where that expertise you were talking about comes in. It's not enough to just follow a manual. You need to really understand how all these tiny details work together.
Exactly. And this document even gives this perfect example with what's often called the rule of thumb for cantilever tail length. You know, that bit that sticks out the back.
Yeah,
There's this idea that it should be about half the width of the gate opening. Sounds simple enough, right?
it does.
Except it's often totally inaccurate.
Okay, wait. You mean that rule of thumb is no good?
It can be dangerously inaccurate. Like if you follow that rule blindly, you might end up with an overloaded carriage, which could lead to a catastrophic failure.
So what? We shouldn't trust those seemingly easy rules of thumb.
In this case, definitely not. That's why it's so important to rely on the manufacturer's data for that specific gate and its components, not just some general guideline. Precision over guesswork every time.
So it's like, you might get lucky, or you might end up with a really dangerous situation.
Exactly. And that's the thing about automated gates. They need a different kind of attention than we might initially think. It's not enough to just assume everything's fine because it's opening and closing.
Right, right. They're deceptively complex, it seems. So, as we wrap up here, What are the main points you want our listener to take away from all of this? When it comes to automated gates, what's the most important thing to remember?
I'd say the biggest takeaway, the thing I really want to emphasize, is that there isn't a magic formula for safety. There's no single maintenance schedule that guarantees nothing will ever go wrong.
Right. It's about more than just ticking boxes on a checklist.
Exactly. And it goes back to what we were talking about earlier about shared responsibility. Everyone involved, the manufacturers, the installers, the owners, even the people using the gates, we all have a part to play.
And it's an active role, not a passive one.
Yes.
We can't just assume someone else is taking care of it.
And it's not just about going through the motions either.
Mm-hmm.
We have to understand the why behind the regulations, why certain designs are safer than others.
Knowing the hazards, recognizing them.
Exactly, because when you understand the why, that's when you can really start to anticipate problems and prevent them.
It's about moving beyond. I think this is fine too. I know this is safe, and I can explain why.
You got it. That's what gives you real peace of mind.
Peace of mind, and potentially, it could even save lives.
Absolutely. And that brings us to a really important question for everyone listening.
Okay, lay it on us.
Think about everything we've discussed today, the regulations, the hazards, all those little engineering details that make a big difference, and ask yourself, what does all this mean for you?
In your specific situation, right?
Exactly. Are you an owner who's been relying on that rule of thumb for your cantilever gate? Are you an installer who's been assuming the manufacturer's guidelines are always enough?
Or maybe you're someone who uses these gates every day without even thinking twice about it.
Right. And the point isn't to place blame, it's to empower you to ask the right questions, to seek out expert advice when you need it.
To be proactive instead of reactive.
Exactly, so that you can be confident that those automated gates, whether it's at your home, your workplace, or anywhere else, are truly safe for everyone.
It's been quite a journey today, hasn't it? We went from what seemed like a simple question about maintenance intervals to uncovering a whole world of safety regulations, engineering decisions. We even learned about the importance of things like track alignment and cantilever tail length.
It's amazing what you can learn when you really take a deep dive into a topic.
It really is.
We uncover hidden complexities. We gain a deeper appreciation for the things we often take for granted.
And most importantly, we come away with the knowledge and the tools we need to make informed decisions.
Exactly. So if there's one thing you take away from today's deep dive, let it be this. Always prioritize safety when it comes to automated gates.
Couldn't have said it better myself.